and force body you have the two cables, FC and direction, or parallel to the x direction. All right, so we're going to use our usual steps here, sum the forces in each direction. But to do this, we have to break FB and FC into components. P and W are easy because they're along major axes. So for FB, we're going to need a unit vector. We have the magnitude times the unit vector. So just recall that a unit vector is that vector divided by the magnitude of that vector, and then you're left with direction. All right, so I'm going to make it so we can see my diagram. So the unit vector for AB is first the vector AB. So in the x direction, when you move from A, when you go from A towards B, you are moving in the x direction a negative 1.2 meters. I'm going to not put the units on here. We know everything's in meters. Okay, so minus 1.2 I. Now in the j direction, when you go from A to point B, you're going from 2 meters to 12 meters. So that's 12 minus 2 in the j direction. And then in the k direction, you're going from 0, because this is over the x-axis, out to positive 8. So that's a plus 8k. Now this whole thing goes over square root of minus 1.2 squared plus 10 squared plus 8 squared. And when you do that out, you end up with minus 0.093 I plus 0.78 J plus 0.625 K. All right, do the same thing for C. Unit vector for C, minus 1.2 I plus 10J minus 10K. All that over square root of minus 1.2 squared plus 10 squared plus minus 10 squared. That yields minus 0.085 I plus 0.704 J minus 0.704 K. All right. So let's write our forces out. So now we can express the vector force in the B direction has a magnitude that we don't know yet, times minus 0.093 I plus 0.78 J plus 0.625 K. We can express C as the magnitude of C times minus 0.085 I plus 0.704 J plus 0.704 K. Nope, it's a minus. There. All right. So, for these guys, we know the directions, but we don't know the magnitudes. So for the whole structure, we're going to start with, it doesn't matter which of these you do first, I'm going to sum the forces in the x and set them equal to 0. Now instead of doing that, I'm going to do it by forces to the left equal forces to the right. No negative signs, right? So forces to the left is going to be FB times 0.093 plus FC times 0.085, and that all equals P. Sum the forces in the Y. So we're going to have FB times 0.78 plus FC times 0.704 equals 200 times 9.81. These were up equals down. Okay, mg. And then sum of the forces in the Z. Magnitude of B times its unit vector equals the magnitude of C times its unit vector. Okay, so we're in pretty good shape here. We have three equations, 3 unknowns. This is solvable by algebra, and I'll just give you the result rather than go through all that. You end up with P equal to 235 newtons. FB equal to 1,401 newtons. FC equal to 1,236 newtons. Okay. Not too bad. I'll be back with another somewhat more challenging one for our next video. Okay. Bye-bye.